Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 157. Page number 157, problem number 7. It's the same problem that we did yesterday. I want to do it one more time because it did not quite come out yesterday the way I wanted it, so we're going to redo it. The problem deals with the concept of combination and permutation, a very important concept. So here's what's going on. In problem number 7, we are told that we have a manager which is trying to form a 6-person committee, 6-person team rather, to work on a certain project. We are told that from 11 possible candidates, he is to choose these 6 people, and 3 have already been chosen. Since 3 have already been chosen, we're basically left with 8 people, out of which we have to choose 3 more, because 3 have already been chosen. So the problem here is this. 8 choose 3. This is what it's called. So we have 8 people and we have to choose 3. The point here is, the important concept here that we need to understand here is that, are we dealing with permutation or are we dealing with combination? To understand that, let's start out with something simple. 3 choose 2. So we have 3 people, out of which we are supposed to choose 2. Well, how many different ways can we pick a first person? Well, we have 3 altogether. How many different ways can we pick a first person? The answer is 3. Once we have chosen the first person, how many different ways can we choose a second person out of 3? Well, one person has already been chosen, so we're left with 2 people. So there are 2 different ways of choosing a second person. Altogether, there are 6 different ways, it seems like it, of choosing 2 people. Namely, we have 3 people here, A, B, C. We can have either AB or BA. We can have AC or CA, or we can have BC or CB. As you can see, if we're going to claim that there are 6 different ways of choosing 2 people out of 3, the only way that this claim will be valid is when order matters. Because here we're counting AB as one possibility and BA is another possibility. This will be true in a scenario where the position has any significance. Who is picked first and who is picked second has some significance. For example, if we are choosing, for example, president and vice president among the 3 people, then of course it does matter whether we put A first and then B, or B first and then A. Because A is president, B is vice president. In the other scenario, B is president and A is vice president. So here order matters and there are 6 possibilities. This is called permutation. What we hear is permutation. Permutation, as we learned yesterday, permits repetition. We can repeat AB and BA. I count it as 2 different possibilities, obviously, because they're the exact same 2 people, but they are assuming 2 different positions. When the position is of no significance and we're simply picking 2 people, so let's say a team of 2 people out of 3, if you just have to pick 2 people to work on a certain project out of 3, it doesn't matter who you pick first and who you pick second, in which case we have to deal with either these 3 or these 3. We cannot repeat anything. And mathematically, the way we show it is that we have 3 times 2 and then we take half as many. We take half as many by dividing by 2. So if we were picking 2 people out of 6, if we had 6 choose 2, then there are 6 different ways of picking a first person, 5 different ways of picking a second person. There would have been 30 different ways here, out of which 15 of them are pairs. They are replication: AB, BA, CD, DC, EF, and FE, and so on and so forth. So we have to take half as many. So 30 represents the permutation. Permutation permits repetition. When we take half as many, because we are repeating now, that is called combination. Combinations. There are 15 different ways of picking 2 people out of 30, 15 different combinations where order does not matter. So here we take half as many. Let's do one more. What if we had to pick? What if we had to pick 2 out of 4? 4, choose 2. So in which case there are 4 different ways of picking a first person. In which case there are 4 different ways of choosing a first person, and then 3 different ways of choosing a second person. There's going to be 12 different ways, and we'll see this in a second here. There would be 12 different ways. A, B, C, D, A, B, B, A, A, C, C, A, A, D, D, A, B, C, C, B, 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 D, D, B, and finally C, D, and D, C. Now, out of these 12 different ways, as you can see, 6 there are repeats, B, A, and A, B, and so forth. So, how many different combinations are possible where order does not matter? The answer is we have to take half as many. We have to take half as many. So, we take only 6 of them. Only 6 of them are counted. So, it's 6 times 3, rather 4 times 3 divided by 2. We take half as many. Let's make it a little bit more complicated. Let's choose, we have 4, let's choose 3. And see what happens here. When we are choosing 3 people, things get even more complicated here. So now what's going on is that we have already chosen 2 people. That's how it is done. We take care of the pairs first. We have already chosen a pair. First we choose, we do not choose 3 people in one step. If we are asked to choose 3 people, first we have to pick a pair. And we ask ourselves, how many different ways are there of choosing a pair out of 4 people? And the answer is 6 different ways. Because as you can see, this 6 is the same as this 6. We either deal with this 6 or we deal with this 6. So that takes care of this part. This is how many different ways there are of choosing a pair. Once the 2 people have been chosen, how many different ways can we choose a third person? Well, if we choose A and B, then we can have either C or D. If we choose A and C, we can have either B or D, and so on and so forth. Of course, there are 2 different ways of choosing a third person, because there are 2 people left. Now watch what happens here. Again, keep in mind that we either deal with these 6 or these 6. We do not deal with both of them. It's either this or that. So we're going to deal with these here. See what happens here. I'm going to rewrite these things in a little bit bigger letter here so we can see it. A, B, A, C, A, D, B, C, B, D, B, C, B, D, and D, B. I don't remember what the last one was. Let me redo it. A, B, C, D, A, B, A, C, A, D, B, C, B, D, and finally C, D. So these are the 6 possibilities. Now we're going to choose the third person. Now we're ready to pick third person. And watch what happens. Pay close attention and so we'll see what happens when we pick a third person. When we pick a third person, we either have A, B, and then we have C or D. We have A, C, we have B or D. We have A, D, we have B or C. We have B, C, we have either A or D. We have B, D, we have either A or C. And we have C, D, we have either A or B. What do you notice? What we notice here is that as we choose third person, we begin to see a triplet. Before we had duplication, now we have triplication. The reason we divided by 2 is because we had duplication. By the time we pick a third person, we begin to have triplication. As we can see here, we have ABC, we have ACB, we have BCA. You see? Similarly, we have the triplication of the other one. We have triplication of the other one. We have ADC, ACD, ACDA. You see? I'm going to put it in a box. CDA, ACD, ADC. You see? We have triplication. we begin to have triplication. Of course, we cannot count the same 3 people 3 times because order does not matter. So however many different ways there are of picking a third person, we have to take third as many. We have to take third as many. And that's your answer. This is how many ways there are of choosing 3 people out of 4. And of course the answer is there are only 4 different ways of choosing 3 people out of 4. Why? Because there are 4 people here. A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. And why are there 3 different ways of picking? Why are there 4 different ways of choosing 3 people out of 4? Because if you have to pick 3 people out of 4, essentially what we're doing is that we are not picking one person. And there are only 4 different ways of not choosing one person, which is to simply either not pick D, or we cannot pick C, or we cannot pick B, or we cannot pick A. There are only 4 different ways of not picking one person out of 4, which is to just not pick one, just drop 1 out of 4. And there are 4 different ways you can drop one person, which is same as saying pick 3 people out of 4. There are 4 different ways. As we can see, this is the mechanical thing. Now if we had more than 4, it's not going to change anything. Here we have 6, choose 3. In this problem we have 6, choose 3. It's not going to change anything. It's the exact same thing as before. Since there are 6 people, there are 6 different ways of choosing a first person, 5 different ways of choosing a second person, 4 different ways of choosing the third person. And as soon as we went too far here, there are 6 different ways of choosing a first person, 5 different ways of choosing the second person. Once we have chosen the 2 people, once we have chosen the pair, we stop ourselves and we say to ourselves that since everything is being repeated, this thing has to be divided by half, divided by 2. And by the time we pick a third person, there are 4 different ways of choosing a third person. By the time we choose third person, we have to divide everything by 3. Now in this particular problem, problem number 7 that we're looking at here, in this particular problem we have 11 people, out of which 3 have already been chosen, which means there are 8 left over, and we have to choose 3 more out of those 8 because we want to form a committee of 6 people out of 11. That's what we are told, and 3 of them are already chosen. So here we have 8. It doesn't change anything. So there are 8 different ways of choosing the first person, 7 different ways of choosing a second person. We take half as many, and by the time we choose a third person, there are 6 different ways of choosing a third person. But by the time we choose a third person, you begin to see triplication. Since we begin to see triplication, we have to take a third as many. That's it. That's your answer. 2 times 3 is 6, so this 6 drops out, and the answer simply is 8 times 7. 7 times 7 sevens are 49. 49 plus 7 is 56. And that's your answer to problem number 7 on page number 157, the very first problem that you see on page 157. I'll see you tomorrow, or we'll do the other 2 problems. Alright? Bye now.